Hey, this video is going to be about how to use the Adafruit Circuit Playground to learn how to program. So this is a variety of Arduino. And so the first thing we're going to do for this is let's go ahead and take a look where to buy this item. So Adafruit is a really great website for buying parts, but then they also have explanations and tutorials how to do things. And if you look for the Circuit Playground, they have a bunch of different options, and the one that I use is the cheapest one, and that's this one right here, the Circuit Playground Classic. So you can buy it there. You can also buy it on Amazon. And this would be called, you would consider this the same thing as kind of an Arduino. The big thing that's different is, as you can see, this has a bunch of lights already attached and sensors attached. So a lot of times when people work with Arduino, there's wiring, or most of the time, and that stuff's really fun. But the benefit of this is that you can focus just on the programming, and you can worry about the wiring for later, and then you can get a little better idea of how to get started. So the first thing you need to do is get the Arduino program, and so for that you can just download Arduino. It's going to pop up like this, and then choose whatever software it is you have. You click it down here, download it, and install it, and then once you get it, it's going to look kind of like this right here. And so we'll talk about that in just a second. The other thing I've attached to this video is going to be a data sheet that's talking about how it is that you work with this device. That's the Circuit Playground information sheet. And I've been teaching this to middle school and high school, so I've kind of created it for at least beginning in that level. There's a bunch of information here we're going to talk about. It talks about how to download the program we just talked about, and then also this, how to connect to it, which we'll do in just a moment. There's also a bunch of terms here that we may get to a bit later, and on the back there's some code. So these are bits of code for things you want to do. We'll see, like for example, the first thing we do is turning on the built-in red LED, and so that's the one that will do it for us. Okay, so let's take a look here and let's go back to our program. So this is your Arduino sketch, and the first thing we want to do is we're going to save this. So I'm going to call this save as, and it's automatically going to save to your documents Arduino. So I'm going to call this Ghost Popsicle Circuit Playground. And I'm going to use the same file throughout the different videos I list. I'm going to have them go in order, and so when we finish one, we'll keep the same file to go on to the next. Okay, so the first thing we're going to take a look at is, in this code, there's two main parts. There's the setup and the loop. The setup runs one time. The loop runs over and over and over until the device explodes, basically, which would probably be a whole bunch of years. And so one thing we need to do at the way top above this, and this is because we're using the Circuit Playground, it has kind of its own, what's called its own library file, its own file that will be kind of a helper file. And so we want to bring that in. We're going to hashtag include, which means to bring that file in, so we're using that. And it's going to have a less than sign, Adafruit underscore circuit playground dot h. And so that right there, the capital and lowercase really matters. These here, if you've ever wondered, if people, when you see this later, sometimes instead they'll use quotes. And the difference is, if it's in quotes, it's looking for the file in the particular location related to this file. Whereas if you use these greater than less than signs, it's looking for it in your general libraries. Don't worry about that for now. The next thing we're going to need to do is anything here that has two slashes, that means that it's notes, meaning the computer doesn't actually look at it. It's just for you and I to look at. So that tells us we're supposed to put things that are supposed to run once there, so we can delete that because we understand now. And so the first thing we're going to do is we're going to begin this Circuit Playground. So we're going to type Circuit Playground dot begin. And what this is going to do is it's going to start up the device, it's going to start up this file and everything like that. So we begin the device. Okay, great. That's all we have to do in setup. And the next thing we're going to do is in loop. So in loop here, we're going to do the very first simplest possible thing. And so what we're going to do is we're going to try to blink the LED that's built into the Circuit Playground. And so I'm going to go and show you what's on this thing right here. So here's a close-up of the Circuit Playground. I'm going to point out some of the parts here. And right now you can see it's blinking because one of the programs we're going to do I've left on there. And that's where it listens to the volume of my voice, and then it blinks those lights a certain color. Okay, so here's the USB where you're powering from. This light tells you that it's on. Here's number 0 NeoPixel number 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10 of those, and they're called NeoPixels. They have a red, green, and blue component, so they can be any color. This picture of an eyeball. Right next to that, there's going to be the light sensor. And so the light sensor can actually determine how bright the light is. So from, I think, 0 maybe to a couple hundred. Over here, you've got, there's a picture of a musical note. This is a speaker. This is just a buzzer, so that can play tones. Here you've got the left button on the left here. And here's a switch that can be left or right. You can use for anything you want. Over here with a picture of the ear, that's a microphone. It can't record anything or decode. It can just tell how loud things are. Right here is the right button. Here is a thermometer. And right in the middle, this is the accelerometer. So this gives you X, Y, and Z. So that would be like tilting a video game controller left, right, forward, back, and then checking how flat it is. That would be Z. So that's pretty much everything aside from this reset button. All the other components, it doesn't really matter what they are. But the last thing, number 13 here, that is the built-in LED. So that just blinks red, and it's mainly just for testing purposes. And so the first thing we're going to do is learn how to flash that. So in the loop here, go ahead and we're going to type circuit playground dot red LED, and we want to turn it on. So we're going to tell it to go high. So this is the particular function that turns the red LED on. And I'm going to go back to that sheet that I've attached here to show where that is. So right here it says circuit playground red LED. High is to turn it on, low is to turn it off. And you can see that we'll use some of these other functions as we go through. Okay, so now that we've turned it on, let's go ahead and let's have it blink. So what we're going to do is we're going to have it stay on for a certain amount of time. And this thing we're doing now is the standard, excuse me, first tutorial that anyone does in Arduino, and it's a good one. So we're going to make a delay. So what this means is we're going to wait a little bit of time before the light changes, turns off. And so we're going to give it 1,000 millisecond delay. So that's 1,000 thousandths of a second is 1 second. And now that it's been on for 1 second, we're going to turn it off. And so if you're lazy like me, you can take all that and you can copy it with Command C, or you can right click and copy. And then right below it, you're going to paste, Command V, or right click and paste. And this is going to turn the light, and now we want to turn the light off. So capital LOW, and you can see it lights up green, showing you that it understands the command. And so now it's ready to run the first program. This function here will turn it on, wait a second, turn it off. We just have to make sure we're connected properly. So connect your Circuit Playground by USB to the computer, and up here at the top you'll see it says Tools. So first thing we have to do is tell it which device we're using. Earlier today I was using this, which is a different type of Arduino. That's not the one we want. We want the Circuit Playground, and because this is popular, it's going to be included anyway without having to do anything. So you click on Adafruit Circuit Playground, and the next thing you have to do is make sure that you've got the right USB port attached. So under port, you should see something that has the word USB in it. For PC computers, sometimes it says COM. Sometimes you'll have two devices plugged in. This tells you which one is which. So make sure that's attached. And then what we're going to do is we're going to go ahead and we're going to upload. And so up here at the top left, there's a little arrow. Click the arrow to the right, and that's going to upload the sketch. On the bottom left, it's going to say compiling, making it into machine code. And when it finishes compiling, it's going to go ahead and it's going to upload it, and it'll tell you that it's done here when it's finished. And then we'll take a look at what happens. There it says, let's see, uploading. All this stuff at the bottom here, unless it's red, you don't have to worry about it. Let's take a look at what it looks like. And you can see here that little red light is going on for 1 second and then going off for a second. And so we're just going to play with it a little bit so we understand it a little more. So this is the amount of time it's on. This is the amount of time it's off. Let's try to turn it so it's on for 500 milliseconds and off for 1 full second. So I'm going to upload that. And here it finishes uploading. So I'll take a look. Now it's on for only half a second, off for a full second. And let's see if we can go faster. Let's have it on for 50 milliseconds, off for 50 milliseconds. It's going to be pretty fast. So you can see it's blinking on pretty fast and off pretty fast. Okay, so what I'm going to do as I do these things is I'm not only just going to teach you the smart way to do it, I'm going to teach you kind of the clunky way to do it first, and then afterwards the smart way, or the more efficient way, to kind of see the comparison. So what we're going to do now is, because that number 50 is going to be the same for on and off, instead of having to type it over and over every time we want to change it, we're going to make a variable to hold that right there. And so for those milliseconds, I'm going to choose a variable that's an integer type. Integers can be basically negative about 30,000 to positive 30,000. And so we're going to create an integer, and we're going to call it delay time. And when you create the name for a variable, you want to use what's called camel case, which means the first letter is lowercase, and every new word is capital. And that's going to matter. It's going to make a difference in making sure they're typed the same, but it also just is easier to read the words. And we're going to give it the value of, let's change it to 100. And so we're going to make it so the delay time is 100. And in here, now when we're delaying, instead of delaying by 50, we're going to substitute the variable from above, delay time. And I'll just go ahead and be lazy and select this, right click, copy, and in here, paste it. And so now when I upload, when it looks at delay time, it's going to use this variable, and that variable could change if we wanted it to. Okay, it uploads. Let's take a look over here. So now it's 100 milliseconds each way. Okay, the next thing we're going to do is we're going to organize our code a little bit. So everything that happens inside the loop goes on forever and ever. But if we wanted to now change the program, we would kind of have to delete this and then write something else, which would mean we're constantly deleting our code. So we're not going to do that. We're going to make this what's called a function, which is kind of like a little subprogram we can say to use or not to use. So select everything we've typed so far in the loop. Make sure you leave this curly bracket and this curly bracket alone. So select all those, and we're going to cut it. So you can right-click, cut, and then way down below here, what we're going to do is we're going to create the name of a function, a mini program, and we're going to call that blink LED. Open, close parentheses, space, put a curly bracket, and when you hit enter, you can scroll down and see that it automatically created the closing curly bracket for you. And in there, that's where we're going to put the function that we just copied. So I'm going to right-click and paste it. And so now there's a function called blink LED. And if we call that out in the loop, it's now going to do all this stuff. So I'm going to go here to the loop, and I'm going to tell it to do something, because right now nothing's going to happen. I'm going to say blink LED and put a semicolon. The semicolons we've been putting at the end are called tokens, and they're like periods at the end of the sentence. And if you don't have one, it's going to generate an error. So we're going to go ahead now, and when we upload it, it's going to run this setup once. Then it's going to run blink LED, which means it's going to look here. And then afterwards, it's going to run blink LED again, which means it's going to look here, and then keep doing that until basically the world explodes. So I'm going to upload this. Everything should look exactly the same over on this end here. It's just that we've made it a little more efficient, and we're going to keep doing things that way. So you can see it's still blinking just like that. Okay, so the next thing we want to do right here is we're going to make another function. And so now that we get the first one, we're going to slash it out, which means that the computer doesn't look at it. And later on, if we want, we can take those slashes away, and then it'll run again. This way we can keep a bunch of programs easily stored so we can turn them on and off. The next thing we're going to do is we're going to light up all the pixels. So we're going to say light all pixels, open, close, semicolon. So now it's going to only do one thing in the loop. It's going to run the light all pixels function. But since we haven't written that yet, nothing's going to happen. So what we're going to do is, because we're always going to be creating new functions, we're just going to keep pushing them down and making new ones. So from the beginning, we've got our include, our setup, our loop, and now we've got our next function, and then our older, as we go down, our functions get older. So we're going to say light all pixels, open, close, space, curly bracket, and when you hit enter, you see it automatically generates the ending curly bracket. And so now we're going to do this light all pixels function. And so, like I said, we're going to start doing it kind of a simple way. Eventually, it'll be kind of the efficient way. But the first thing we're going to do is learn how to light one pixel, one color. So we're going to use this function that I've got in this sheet here. That is Circuit Playground set pixel color. And then in there, the first thing is going to be which pixel number it is, 0 to 9. The red, you're going to type a number from 0 to 255, which is the maximum. Same with green and blue. So 0 is off, and 255 is the maximum amplitude, or the brightest it can be. And that's how you turn on one of those neopixels. So in here, we're going to do that exact thing. We're going to say Circuit Playground, make sure those capitalizations are correct, dot set pixel color. And so now we're going to tell it which pixel to turn on. We're going to, for now, we're going to say turn on pixel 0, and we're going to say that we want pixel 0 to have a red value of 255, a green value of 0, and a blue value of 0. Then we're going to close semicolon. So this is going to turn on the 0th or the very first one, the closest to the green light, it's going to turn on this pixel red only. So I'm going to go ahead and upload this one. Oh, looks like I probably made a mistake. Let's see, what did I do? Light all pixels. Let's see here. Expect a constructor before the semicolon. Let's see, I'll do a little troubleshooting. Close this here. Okay, excuse me, it's too early in the morning. I forgot you got to type void before these, and that basically tells it that there's going to be a function right there. So I'm going to go ahead and upload this here, and it's going to just set that 0th pixel to the color red. Right here. So that goes ahead and that turns red. Okay, so go ahead and you're feel free to mess around with that. So like for example, you could change it so that the blue is 255 because red plus blue equals purple. And so that should go ahead and that should change this one to be the color purple. Right there. And so that's how you change and make one pixel one color. And so the next thing is, let's work on how we're going to make them all one color, or all different colors. And so if we want to make the next one, first we're going to do it the inefficient way, which is we're going to go ahead and copy this and paste it here. And let's just say we now want to turn the first pixel that color. And I could even take these two and I could keep going. I can make the second pixel this color, and I'll do one more. I'll do the third pixel. So now we should have 4 pixels that are in color purple, and you can see it took a lot of work to get there, and if we wanted to change it, we'd have to change a bunch of values. So now we're going to find a more efficient way to do this. We're going to use a for loop, and so what I'm going to do is press enter here, and so instead of this, after what we do, we're going to delete all of this, but we're going to leave it there for the moment. So what we're going to do is we're going to say for, and we're going to now choose a variable for the 10 times we're going to do this. We're going to use a type of variable called a byte. So byte I equals 0, semicolon, space. Oops. So we're going to do this as long as I is less than or equal to 9. And I'll explain this in just a moment. We're going to add 1 to I each time. And curly brackets, enter. So basically what we've got here is we're saying we're going to do something. And the thing we're going to do first, we're going to do it where the number is 0. And then we're going to do it the next time where we add 1 to that. And now the number is 1. The next time the number is 2. Then the number is 3. All the way up to I being less than or equal to 9. So it'll work for I is 0 all the way through I equals 9. So the thing we want to do is we want to say circuit playground set pixel color, and we want to set it for pixel number 0, then 1, then 2, which is I, and we want to say 255, 0, 255. So what this is going to do is we can delete all of this stuff because it's going to set the pixel color as that for 0 pixel, then 1, then 2, then 3. So if I delete this here, and if you hit Command T, it'll auto-format things for you. Oops, auto-format things for you properly. Find my function. Type all pixels here. That's all right. That's my semicolon. There. So let me upload this, and then it should have all the pixels light up with that one color. Gotcha. So now the idea is, if we type light all pixels, it's going to light them all up, but it's going to light them all up purple. We want to be able to light them all up with different colors each time. And so the trick for that is we've got a red value, a green value, and a blue value. We want to be able to type those in here. Like for example, we want to be able to say 255, 0, 255, and that lights them all up any color at any given time. And so to do that, what we're going to do is inside here, in this parentheses after light all pixels, that's where we're going to say what the input is. And so we're going to say the first one is going to be a number that goes from 0 to 255. And so instead of using an integer, which we used before, an integer is this is like a bucket trying to hold a thimble full of water. An integer is huge. If we only want to store a small amount of data, we use a byte. So a byte can hold the number from 0 to 255. So we're going to make a variable that's a byte that's called red, Then we're going to make another one that's called a byte that's called green, and then a byte that's called blue. And so this is going to allow you to input what those variables are. That will be inserted for red, and we want that to go right here. And then this next number here, that's going to insert green, the green amount, so that goes here. And then this one here is the blue amount, so we want to put that one here. And so now what this is going to do is the identical thing. It's going to give the value of 255, 0 to 255, which is purple. And so nothing should change. You'll see the blinking lights showing it's updating. Everything's the same. And now let's check if it's different. Let's come here and let's change the value. Let's say 0, 255, 255, which is green and blue. And there's our data transmitting. And there it changes to cyan. And so this is a simple function you can do. And so if we wanted to, we could do more things like this. So if we wanted to, we could do 2 of these in a row. So we could say, first light all pixels that much. And then we could say delay by 1,000 milliseconds, which is a full second. And then we could have it change a different color. And that different color, let's say, is only red. In fact, let's make the first one only red. Let's make the next one green only. And remember, we want to wait a second between each one. And we want to have this one here. In fact, I'll just copy this whole thing. Be blue. So now it should cycle through red, green, blue with a second on each. And so we're using functions inside other functions. In fact, we want to keep our loop clean here. And so what we're going to do is we're going to take all of that stuff, those 3 light all pixels, and we're going to cut them. And we're going to come down here, and we're going to keep things clean by making another void. Let's call this cycle colors. And inside there, that's where we're going to put all the stuff we just did. So we're keeping blink LED in the loop. This is the red, wait a second, green, wait a second, blue, wait a second. And in order to make it actually do anything, we're going to have to call out cycle colors, which will go ahead and cycle those 3 colors. And just like we did for the blink LED, because this 1000, we would have to type it 3 times to change it, we're going to go ahead and we're going to make an int delay time. And then we just take this delay time, copy it, and paste it for each of these. And that way it'll be easy to change. Like for example, if I want to change it to 500, I can upload that and it's going to do the exact same thing. It's just going to go faster. You see it's uploading here. Okay, so here we created a blink LED. We created our light all pixels function. In fact, just so we remember what we did, I'm going to go ahead and I'm going to put another one here. Light all pixels. And our example was red. This will help us remember how to do things. And we're going to slash that out. And so the idea here is that we're going to keep adding to this. So I'm going to end this video now. And if you want to watch, go to the next one, you would just pick up here. You would take the same code. And I think I'll probably maybe export the code so you can upload each time. Okay, thanks so much for watching.